Good morning. Today I am going to explain to you about the fundamentals of the nanomaterials. Okay, my name is Idris Kabalci. This course under the nanotechnology and nanomaterials. So let me carry on in second course based on the fundamental concept of nanomaterials. Ladies and gentlemen, we have several classes covered from the introduction to till application of the nanomaterials. Will be useful for the and for understanding of the concept of the nanotechnology and nanomaterials. So this is the fundamental of nanotechnology and nanomaterials. To be able to start the nanotechnology and nanomaterials, there are many concepts should be understood. One of the fundamentals concept is quantum mechanics and the atomic structure of the materials. Because in the 19 years, there was a big transition from the classical mechanics to modern quantum mechanics. So after the quantum mechanics developed and explained the microstructure and atomic structure of the materials, nanotechnology based on the devices developed very quickly. So after the 19th century, due to the quantum mechanics based devices, increased in industrial application. By the way, due to this increasing application of technology, industry, aviation, and environmental application, in your environment, there are many devices based on the quantum mechanics. For example, if you want to learn something about the Industrial Revolution, means Industrial Revolution 0, Industrial Revolution 1, 2, 3, and the Industrial Revolution 4, and it could be 5, based on the application of quantum mechanics. So one of them is IT. It means that the information technology, which is impacting everyone's daily life. Without IT, it means that the information technology, nowadays, it seems to be a little difficult to share the knowledge and the information. Like this, by using the internet, it is really efficient of the communication, exchange, trades, and education, and the medical application, and the geographical situation is possible. So one of them is actually based on the computers. It means that the computers, especially based on the semiconductor materials. It means that the semiconductor materials could be considered as between the insulator and between the metallic materials. It means that the computer, we can able to classify it as for example, if we want to categorize the materials, okay, materials. Or we can able to write here okay, materials might be divided three parts. One of them is we can able to say conductive materials. Okay, conductive materials. And the second one is that we can able to write it. It's a insulator. Insulator, and then the other one might be, we can able to write it, it's a semiconductor materials. Okay, so as you can see here, materials according to the electrical properties could be divided in 3 groups. One of them is a conductive materials, second is a semiconductor materials, and third one is the insulator. So based on the semiconductor materials, like we can able to write it like germanate and like a gallium, like a silicon. So this kind of materials has been used in the integrated circuit elements. By the way, this kind of semiconductor materials based on the computer structure. For example, integrated circuit elements, transistor, diode, and the PNP junction-based devices. So that's the reason computer is completely based on the quantum mechanics. Okay? So quantum mechanics is based on the computer is based on the semiconductor materials. Also, all this kind of iPods, digital camera, cell phone, all of these is compromised and make the development of the IT technology-based devices. That's the reason, if you want to learn the structure and the properties of the IT-based devices, so you need to understand the quantum mechanics. What about the other application, like photonics, like electronics, like biology, chemistry? All of them are based on the quantum mechanical application. So without these consumer electronic products would even be possible without quantum mechanics. It means that this digital watch, these LCD screens, this camera, iPhone, all of them is based on the quantum mechanical application. And to start the quantum mechanics, it is the good points before understanding of the nanostructure, nanoscience, and nanomaterials. So to be able to understand the nanotechnology and the nanomaterials, we need to explain some concepts from the quantum mechanics. So you need to become familiar to the concept of the quantum mechanics. So as you know, maybe it's my pleasure to remind you some of the fundamental theory of the quantum mechanics. One of them is a Newtonian mechanics. It means and the Maxwell theory of electromagnetic field. So before the 19th century, there was a Newtonian mechanics considered the materials as a macroscopic scale. But later on, Maxwell theory tried to open some innovation related with the quantum mechanics. And the second one is quantum mechanics. So quantum mechanics, first of all, based on the Max Planck blackbody radiation. And then, while trying to give a theoretical derivation to the formula of blackbody radiation. And the blackbody radiation, based on the Max Planck theory, try to explain the energy level of the materials. But later on, Einstein considered the Max Planck theory, extended it to be able to explain the photoelectric effect. So after the Max Planck theory, there is an Einstein theory related with the discrete energy level of the materials also.